Hey everybody, Joe here. Gonna check out a puzzle today called Bishopsgate by Cris. The rules are normal Sudoku rules, that's 1 to 9 in every column, row, and 3x3 box. There is a bishop's constraint on the white squares of the checkerboard. The cells on each white diagonal are different. Please note that playing... oh yeah, okay. Cells connected by a V or X sum to 5 or 10 respectively. Cells connected by a white dot are consecutive. So those will be consecutive numbers. X's will be 10s, V's will be 5. B's will always be made up of small numbers. X's will always be made up of a low and a high, as in a number below 5 and a number above 5. So in this column, we'll have 4 lows accounted for in those 6 squares. So we know that this, and this will be of a high nature, or 5. These two will be high. These 6 will also have 4 lows in them. So these 3 here will be 5 or high. These 4 numbers are all on white bishops. So they are all 4 different. As in this one cannot be that one or that one or that one. This one, yeah. Those are 4 different digits. We'll do a thing like that. So this cell here that sees all of them cannot be low. It will be high. This will be low. One, two, three. The 4th high is gonna be, okay, a 5 goes over here somewhere. If this was pink, then this one would have to be green. because they would be a set, so to speak. But then both of them, pink and green, would both need to be in this row here, and there is no room for that. So this one and this one are red and yellow. Which means that this one and this one are green and pink. Which means that this one is high. And this one is low. That'll be red or yellow. This will be green or pink. This one cannot be red, green, or pink. I don't think it can be yellow, because if it was, yellow would have to go here. Or, well, what I should say is, if this was yellow, where would yellow go here? It wouldn't be able to go here because of bishop. Wouldn't be able to go here because of the row has both already. And it wouldn't be able to go here because of bishop. So this cannot be yellow. And it can't be red. It can't be green or pink because of column. So this is only, that must be a 5 then. And this must be a 4. And this must be a 1. And now this cannot be a 5, therefore. Yellow is not a 4. This is a 2-3, so this will be a 7-8. That is a pair. Green is not 1. Pink is not 1. So this is not 6, this is not 9. This is a 9. There's 7-8 pair here. That is a 9. This is a 1. That is red. This is a 6, because again the 7-8 pair. This is a 4. So 1 and 4 will be over here. So 6 or 9 will be there. So this is 2, 3, 5. We have a 2, 3, 4 triple. So there's a 5, 7, 8, 9 in the rest. This cannot be a 4, so it's going to be a 6, 7, or 8. else do I have? Can this be green? Pink. If it was pink, it would be there or there. That seems fine. This digit, 2 or 3, will end up here somewhere. This 2, 3 cannot be there. This pink or green will be in one of those. So this is yellow. Because yellow cannot be here because of bishop. Can't be here because of row. That is yellow there. This is therefore yellow. This doesn't quite do it. The yellow will be here or any of them. Or one of those. So where was it? There. This is 2 or 3. It's gonna be a 7 or 8 up here with either a 6 or a 9. Oh, well, it'll be a 6. Because 6 cannot go in this column, it must go in this one, so therefore this is not a 6. So it is not a 4, it is a 1, 9, this is a 4. So red will be here, one of these. This is green or pink. That's on a gray. This will have a 9 and a 2, 3. be either green or pink. So 5 will be down here. With a 7 or 8. 6 will be down here with a 7 or 8. It's very odd looking for combos in a diagonal. I think this must be the first puzzle I've ever had to do that on. But if we do make one on a diagonal, that'll help us figure out what orientation the other ones are, perhaps. Like we almost have one started here, even with the 6, 7, 8 too. So maybe this diagonal might be worth a look over. Not sure though. Perhaps not. I don't see how these two I can gather much information from at the moment. Soon, perhaps. A 5. A 5 cannot go in this column. Can't go on the X. If a 5 went there, couldn't go there. Oh, I didn't go to no. No. What about if a 5 went here? Wouldn't be able to go there. Would have to go down here. Alright, if a 5 went here, it would go down here. It would have to go here. It would have to go here. It would have to go here. Could not go there. Would have to go there. Have to go in one of those. could not go here. Oh wait. Oh yeah, it would be there. Could not go here because of that one. Could not go here because of that one. So it had to go here or here. So then it would go there. I guess that seems okay. Although, I think if it went here... Oh, that might change other things. Well, let's try this. If it went here... I don't know if I'd be able to do as much with that. It doesn't look like I could. It's not going to give me nothing, is it? Never mind that then. What about in this diagonal? It goes there, there, or there. And then this one, it only goes there, there, there. It goes quite a bit along that one, I guess. I think I'll undo that. Okay, let's look at something else. Five, 7, 8. Oh, well, yeah. Do, do, do. 4 cannot go there, cannot go there, cannot go there. Cannot go there, there. If it is green, green cannot go there. This is a pair. So pink cannot go here. Is that helpful at all? Oh wait, is that pink? Or maybe I should say... I guess it could still be green. Pink and green cannot go here, is I guess what I'm saying. Because one is seen this way, and one is seen from this one. Is that the same for, that's the same for red and yellow. This cannot be a low number then. Red sees it here, yellow sees it there. Pink and green see it there. So this is, that can be a 5 still though. If that's a 5, that's a 5. 5 would be there. 5. That can't be a 5 then. That would break. So that is a truly a high number. What else? Is that going to be the same for this corner? Yellow sees it. Pink and green see it. Red might not though. This could be red, I suppose. If it was red, red would have to go right there. I guess red cannot go there. Red could still go there though. Or go in one of those two. And then red could not be on this diagonal, so it would have to be right there only. So it'd have to go there, then it would have to go here. And then it would have to be in one of those. So red cannot go there. Red cannot go here. Pink and green and yellow cannot either. So this is also a higher number. Can this one be a 5? I don't think I'll be able to know on that yet. One, two, three. Do we have any more? What about this one? Not as good, I don't think. What if I swap these? colors. Made 4, either pink or green. Would that do anything? I don't think it would. It would just give me my hashes that way. Can both these be low? If they were, both of these would be high. This would be 1. This would be 9. These would be low. So they would be green and whichever one of these. Okay. Should I try more on the 5s maybe? Five is there, or there. If a 5 is here, let's go there, there. Would have to go over here and down there, down here. It would have to go in the top, therefore, and it would actually have to go in this one because it would need to be in the diagonal. So one of those. Then it would be, then it would have nowhere here. So it does not go here. If it goes here, it goes there and there again. And then again, it would have to go in one of those. And one of these, one of these. And again in there. Then it would have to go in one of those. I think that would be okay. That one would be okay. If it went here, it goes there. Yep, it would have to go there now because of the diagonal. It'd have to be in the bottom somewhere. I'm not going to get very much this way. be able to go along there. It would be able to go there, any of there. So it would still be on the top, in one of those. It could go there though. Basically anywhere there. Anywhere there as well. I'd have a lot of options that way then, and if it was in the corner. Is that right? I feel like that should be more constricted than that. But I guess it is not. Where do we go here? I feel stuck. Two, three, four. What about these? Lower or high? If this is a 2-3, it would have to be a 1 or a 4. If this was a 1-4 actually, this would have to be a 2 or a 3. So the green, this would be green then, and green would be 2-3. This would be 7-8. And this would also be 2-3, 7-8. Okay. Doesn't seem like it would break anything though. One. Does not go there, does not go there. Does not go there. If red goes there, red goes there. If one did go on X, nine would go here. This would be a 1, 9. That would seem okay as well. Yellow and green have both been on there. This cannot be, green cannot be there. If that was green, I don't know if that's green. Is that green? Let's say it is green. Green would be on the bottom. Is it gonna give me anywhere else? Green would be in the middle. Green would be here only. What about if it's pink? Then it would go like that. One of those. It would be in one of these. And then it would break here. So that cannot be pink. Because there would be... nothing could go in the middle here. Or here. So it had to go here. But these were already forced to take the top two. So it would want to be down here. And it cannot be there. So this is green. Nice. That is pink. So Green and pink are sorted. Good, good. And yellow is with pink. Red is with green. Red is 1. There we go. So now pink cannot go there, cannot go there. Pink goes in this middle. Pink goes down here. Pink cannot go there though, because of this bishop. So pink goes right there. Ah, and that gives me my 5 here. Nice. Pink, it could go here, because that's gray. And we're only worried about the white bishop diagonals as far as the constraint goes via the rules. Pink will be here somewhere. Yellow will also be down here with pink making a pair. Red will be down here somewhere. Green will be down there somewhere. A 4-1. So there's gonna be. These are gonna be 2, 3, 7, 8. 2, 3, 7, 8. 7, 8 comes out of there. 7, 8 comes out of there. We've almost got another thing here. Another combo made. And we're remembering that can only matter on white diagonals. This one is going to do the same type of thing though. It's going to have a... Oh, this will be a 1 or a 4. This will be a 6 or a 9. And then this one as well will be a 1, 4, 6, 9. So 6, 9 comes out of the 3 high ones basically. Oh, and this can't be a 4 because of the diagonal. So that is a 1, 9. That's now a 4, 6 in some order. 6, 7, 8, 9. Oh no. Never mind that. Okay, 1 is red. Let's go ahead and color it. This is not red. This could still be 4. Red is down here, but it cannot be there. So it must be there. And then it can't, or well, can't be there because those are high as well, but It couldn't have been there also because of the diagonal. This one cannot be read now because of diagonal. So this one is. This one is 1. And this one is 9. This cannot be 9. I see a 1. I see yellow. Yellow, red, green. I don't see a pink. This could be pink or a high number. Underwhelming, I suppose. Pink or a high number. Pink does need to go. Where can pink go on the diagonal? It can go there and there as well. It can go in those 3 spots. On the other way, it can go there. Oh yeah, okay. It does quite a lot. It only has this one option in this box though. Same down here. I don't know if ruling either one of them out would be worth a lot of options to go through there. This is on a gray, okay. Can't rule that out. What else do we got? What about 5 again? No, it can still go in the same. Oh, 5 can't be in the corner now because of this. 5 can't go there because of the same. Did that get 5 going anywhere else? Five can still go there. A 5 can basically only go there. It's got the diagonal here. This is red. This is 1. Why haven't I put that in? A 5 can't go here because of the diagonal. Can't go there. Can't go there. Diagonal. So yeah, it's only there. The gray doesn't matter. This is not 5. This is a 6-9 combo here. Oh, well, that does not matter. We're getting down to 7/8. This is the only spot that can be a 5, I do believe. So there, it goes there then. And then it'll go on the top. And yeah, look, it can't be in the diagonal here. It can't be in the diagonal here. So it must go in the diagonal here, and it must go there. 5 is gonna be, this is yellow or pink, so it's not there. This cannot be a 5 because of that one. This one must be the 5 then. And now we have a 5 going right here. From the looks of it, only spot left. And then we have a 5 up here. Nice, all the 5s are done, I believe. High five. Okay. It's gonna be a 1 down here somewhere. There's gonna be a 4 down there somewhere. Whoop. Down there somewhere. And over here is a 2-3 pair. So this will have a 1, 4, 6, or 9. Uh, 6 or 9. Let's just go ahead and do that. And well, this is only a 4 or 6, but this could be 9. Oh, it can't be a 1. Or, I mean, the top one couldn't have been a 9. What am I trying to say here? This looks weird. This cannot be a 1, 4 on the X's. Because then this would be 6, 9. And then over here there would be no fill. Actually, did I just get 9 out of both of those? I did. So, oh well. It does not mean 9 goes there. There's something peculiar going on over there. That's 9, 4, 6. Yeah, so we have a 4, 6, 9 triple. So this is 7 or 8. I mean, I don't know if that's very strange or not, but both 7, 8 are now in this diagonal. This is not 7 or 8. It is a 2 or a 3, so it is pink or yellow. Which might be good to mark. Pink or yellow will also need there will be one more in the diagonal somewhere. Okay, so do we have anything at 2, 3, 7? We have 3 of those. 2, 3, 7, 8. I guess this could still be a 2 or 3. A pink or yellow. I do need a pink here somewhere. Pink could still go there or there though.
Yeah. Pink looks like it almost has to go up on the diagonal on this one. But maybe not. I think it could still go down here. Yeah, probably. Okay, let's move on. So, what about some low numbers over here? I think the 4 probably goes up here, doesn't it? Yeah, it does. Green does go up here. So green does go in the middle here. Can be either. And green does go in the middle here. And then green goes right there. Okay, so that is good. This is not green. This is not green. So this is green. That will be not green. This will be green. This will be red. Alright. This will be 4. This will be 1. This will be 6. This will be 9. That'll give us a few more. That'll give us a 7-8 combo there, making that a 9, making that an 8 for consecutive. This has had a 1 and a 4. Oh, this is a 4. So it sees a 1 and a 4. This is gonna be, oh, the 7's in the cage as well, or in the 3x3. So this must be an 8-2. And this is gonna be a 6-3. So the 3 will go down here, and with the 6 as well. And this will be a 1. 1 is red, and 1 cannot go on this diagonal. So red, that'll be 1. And that'll make that one the red 1 as well. So this will make red. This is not red. This is red. And this is with a 2. Yes. 2 is pink or yellow. Can't be yellow because of diagonal. Now we have a 2, 3, 7 in that column. That is an 8. Oops. 8. This is a 2. I get a 2, 8 sorted over there. 6, 7 paired. Looking at this 8. 2, 3, 9. Okay. This will be a 3, 7. A 3 is going to be, oh well, a pink is 2. Now, and a yellow is that's on a gray. So that is okay. That's going to give us a 6 can't be on the same here. That must be 7. That was nice and easy when they put it right next to each other. Didn't mind that. 3 is on this diagonal already. This is 6, this is 3. This will be a 5. No, it'll be a 3 and a 7. Okay. This will be a 4 and a 6. Okay, and this will be a single 9. 9 will go down here in the corner. And maybe I just go ahead and get rid of basically all of these colors so as they quit distracting me. I don't think I need them anymore. It did, for some reason, all of a sudden get so much more bright though. There's a 7 on this diagonal. So that must be a 3. And that should be getting it wrapped up fairly soon once I sort out the rest of these. What does this have left? It has a 6 and a 7. The 7 is on the right. 6 there. Yeah, nice little puzzle by Cris. Bishopsgate. Check it out in the link below. Play for yourself. And hope you enjoyed. Please like and subscribe. Thanks for watching. Bye-bye. This is on a diagonal as well. And that will do it. Thanks again, everybody. Bye-bye. Have a good one.